Assalamualaikum class. Good day. So today we shall continue chapter 1 MEC 281, which is interatomic bonding. So in this chapter we shall be able to describe the types of bonding between the atoms. First, let us review on the past lecture. In the past lecture, we had learned about atomic structure. An atom consists of three elements, which is neutron with natural charges, proton with positive charges, and electron, which located at the shell or orbital, which represent the energy level, have negative charges. The combination of neutron and proton is called as nucleus or nucleon. At the periodic table, an element is represented by the atomic number at the upper part, which is actually the number of proton, and at the lower part, it is represented by the atomic mass, which is actually the number of proton plus the number of neutron. An atom with the same number of proton but different number of neutron is called as isotopes. If an atom transfer or give up the electron, it is called as cation. And cation often have positive charges, while if an atom receive or take up an electron, it is called as anion. An anion has negative charges. We also learned about the electron shells. The electron cloud is divided into 7 shells or sub-energy level, which is K, L, M, N, O, P, and Q. So, in this chapter, we shall only focus up to 4th shell. At the first shells, only 2 electrons are present, which is actually s orbital. And then at the L energy level, 8 electron, which consists of 2s and 6p orbitals. And at the third level, which is M level, 18 electrons present, which is 2s, 6p, and 10d orbitals. And at the fourth shell, which is N shell, we have 32 electrons, which is 2s, 6p, 10d, and 14f orbital. Electron configuration are how the electrons are arranged around the nucleus. It is arranged according to the Auber principle, which represent energy level, orbital, and number of electrons. So we could follow the yellow brick road over here to start on making the arrangement of Auber principle. It is applied on every element except for these 5 transition elements, which is chromium and molybdenum, which only have half of the maximum number of electron in the shell. For example, S should actually focus or maximum number of 2 s orbital, but here we only have 1 orbital, and for D we have 10 actually, the maximum number of orbital, but here we only have 5. So chromium and molybdenum are halfly filled element, and we also have copper, argentum, and aurum, which is only have 1 element in the 1 number of electron in the s orbital, but then maximum number, which is 10 at the last orbital, which make them completely filled element. Today, we shall learn about interatomic bonding. There are two types of interatomic bonding, which is primary bonding and secondary bonding. So, primary bonding consists of three types of bonding, which is ionic, covalent, and metallic. For secondary bonding, only one type of bonding occurs, which is van der Waals bonding. The first primary bond is ionic bonding. Ionic bonding, often found in compound, composed of electropositive element, which is metals, and electronegative elements, which is non-metal. The electrons are being transferred to form a bond, and this type of bonding requires large difference in the electronegativity. For example, in natrium, only one electron exists at the outer valence, and in chloride, 7 electrons exist at the outer valence. So, one electron is being transferred so that natrium will have complete 8 electrons at the second shell, and chloride will have 8 electrons at the third shell. So by giving electron, natrium will have positive charge, and by taking electron, chloride will have negative charge. Here are the properties of ionic bonding. Ionic bonding are solid at room temperature and liquid at high temperature. It also have high melting and boiling points. Ionic bonding often have hard and brittle properties. They are poor conductors of electricity at solid state, but good conductors in solution or when it is melted. And ionic bonding is often soluble to water. For example, natrium chloride or the salt. The salt is solid at room temperature, but when it is given heat, it will turn into liquid. These are the example of ionic bonding. Okay, as we have mentioned earlier, it could be a combination of metal and non-metal. So to the left, this element tend to give up electron, and to the right, this element tend to take or acquire electron. So some example are natrium chloride, magnesium oxide, and others. So ionic bonding is actually predominant bonding in ceramic. So most of the ceramics material exhibited ionic bonding. Let us take a look at an exercise in the ionic bonding. With an aid of sketches, describe how sodium and chloride atoms are joined together. So in this exercise, what you should do is you should first sketch the bonding between sodium or natrium and chloride. So you have to take a look at their number of proton first, and before you draw your, these are the answer for questions. I would like to advise you to use different legend for each of the element. So as you can see, natrium uses cross and dot for chloride. So first, you should draw natrium and chloride before the bonding, before the electron being transferred, and then you should draw how the element look like after one of the electron are being transferred to chloride. And then in this question, you should also explain what happened during the bonding. So the question would like you to describe how it is joined together. Other than drawing, you should describe. This is the description. The single electron on the outer shell of the sodium is being transferred to the outer shell of chloride with 7 electrons, which make it 8. Thus, it will fill the valence or the outer shell of the chloride. By transferring the electron from sodium, natrium becomes positive, and by receiving an atom from natrium, chloride will become negative. The different charge in both ions attracted each other and form ionic bonding. Thus, this proves that sodium and chloride are bound together by ionic bonding. The second primary bond are covalent bonding. Different from the ionic bonding, where the electrons are being transferred to another electron. So, in the covalent bonding, the electrons are being shared to form a bond. It is mostly occurs between atoms with similar electronegativities. So, in the ionic bonding, it occurs between atoms with different electronegativities. One are positive and one are negative. But in this covalent bonding, it is between atoms with similar electronegativities. It is found in most elements in the periodic table. It could be metal and non-metal. It could be non-metal. It could be non-metallic element. It could be in elemental solid. The most common one are diamond or carbon, silicon and germanium. Or in group 14 of the periodic table, it could also be found in compound solid. So compound solid is a combination of elemental solid, for example, gallium arsenide, indium antimonide, and also silicon carbide. Generally, combination of group 14 and 15. So on your right is the example of covalent bonding, the typical example, which is CH4. So we have carbon. So the carbon have 4 atoms at the outer shell, and to complete it to become 8, so it needs 4 hydrogen, with each hydrogen has only 1 atom. So that as you can see, each of the element shared the atom at the outer shell to produce 8 atoms. 8 atoms to complete an 8 atoms in the outer shell. So it became CH4. So different from ionic bonding, where they transfer the electron. This one they share the electron. Okay. So these are the properties of covalent bonding. So covalent bonding are very unique. It can be either in any condition, which is gases, liquid or solid. It has poor electrical conductors in all phases, meaning to say it cannot conduct electricity. It has very variable properties. It could be hot, it could be strong, could be either have low or high melting temperature, and also have different boiling temperature. But then it has lower melting point and electrical conductivity compared to ionic bonding. And it could also be liquid or gas at room temperature. So different from ionic bonding, which is solid at room temperature. And covalent bonding elements are usually insoluble to water. So it's very different from ionic bonding element, yeah? So at your right is example of covalent bonding at solid state. We have germanium, silicon, and also diamond, or actually made from carbon. So here are example of covalent bonding in the periodic table. So it varies from non-metals, metals, metal and non-metals, elemental solids, and also compound solids, as what we have described earlier. Here are the exercise for covalent bonding. We have single bond covalent bonding, double bond covalent bonding, and triple bond covalent bonding. So how does this bonding look like? Okay. This is how hydrogen bonding looks like. Okay. So in the hydrogen bonding, we have two hydrogen over there sharing with each have only one electron, but to form the first shell, as we have mentioned earlier, the maximum number of atoms at the first shell is 2 atoms. So H2, each one share one electron that make up 2 electrons sharing together. So, and then we have fluoride. So fluorine, we have 2 electrons at the first shell, and then to complete the outer part with each 7 electron, with 1 electron sharing with each other, which complete 8 electron at the outer shell of the second shell. Okay, and then water, we have H2O. Again, to complete 6 electron of oxygen. So 2 hydrogen atom are being shared to complete 8 in the second shell of the H2O atom. And then we also have double bond. Oxygen. So we have double bond to complete in 8. So 6 on the outer layer of each of the oxygen are shared 2 electron shared 4 electron makeups 8 electron at the second shell. And we have triple bonding, which shares 3 electron from the nitrogen shared by 3 electron from the nitrogen. Okay. So single bond only share 1 electron from each other. Double bond share 2 electrons from each other. And triple bond share 3 electrons from each other. That's how you remember how to draw this covalent bonding. Okay, I hope you understand. And then we have primary bond number 3, which is metallic bonding. Different from ionic and covalent bonding, this type of bonding occurs when some of the electrons in the valence shells are separated from the atom shell and exist in the cloud surrounding all the positively charged atom. So this valence electron will form a sea of electron and is found in group 1A and 2 elements and also all elemental metals and alloy. So as you can see, for example, in zinc itself, it has 2 positive charge of proton, but different from other different from ionic or covalent bonding. The electron move freely. It move from the shell. It is not it move from the shell, and it does not orbit the nucleus using the shell. It move freely. Okay, so this is where the metallic bonding occurs. It occurs in all metals, and also group 1A and group 2A in the periodic tables. So what are the metallic bonding properties? Metallic bonding have good electrical conductivity, of course, good heat conductivity. That's why when you touch a metal, when you heat it up, okay, it easily become hot. Okay, it is ductile. That is why it could be formed in any types of shapes. Okay, opaque. Opaque means to say it is not transparent. High density and high weight, and it has shiny appearances. So example of metallic bonding shown here are aluminium, copper, and also the largest metallic bond are the ferrum, or we call it as iron. Okay, we have come to the last bonding of an atom, which is the secondary bonding, the van der Waals bonding. So different from the primary bonding, the secondary bonding is actually rise or form from an atomic or molecular dipole. So what does a dipole mean? It means that it has a pair of equal or oppositely charged or magnetic poles separated by an distance. So this is the diagram of a dipole. A dipole must have positive and negative charge. So that represents an atom with positive and negative charge. So what happens is, along the atom, it has the same atom that are nearby, which create another dipole. So these dipoles also have positive and negative charge. So the relationship or the bonding between these dipoles are called as van der Waals bondings. So the most common type of van der Waals bondings are the hydrogen bondings. For example, we have fluctuating induced dipole bond. We have hydrogen inert gas. So we have two type of hydrogens here connecting together. Or we have polar molecule induced dipole bond, which is actually a combination of two elements. For example, hydrogen and chloride. So this hydrogen and chloride each have positive and negative charges. So these negative charges in chloride also attracted to the positive charges in hydrogen. So the attraction create van der Waals bonding or secondary bondings. And lastly, we have permanent dipole bond. For example, we have hydrogen bonding. So two positive charge hydrogen will be attracted to two positive charge, negative charge oxygen. So that is also called as van der Waals or secondary bonding. So this is an example. How does the model of secondary bonding van der Waals look like? Okay, so the van der Waals bonding is actually the bonding between this atom that already form a bonding with another atom. Okay, so H2O and bond atom with another H2O atom with another H2O atom has a interconnecting bonding, which we call as van der Waals bonding. We have come to the summary of all bondings. So generally, 4 types of bonding. 3 are primary bonding, ionic, covalent, and metallic, and 1 are secondary bonding, which is the van der Waals bondings. So shown here are the bond energy, melting temperature, hardness, conductivity, and also other description. So you could look at all the summaries, and I shall ask you about the difference between all bonding at the next class. So that is all for today. Thank you, class, for your attention, and I hope to see you in the next class. Thank you.